An asteroid hurtling towards the Earth is something real-life scientists are preparing for at NASA. Live in Los Angeles, in the last 5 minutes, Cern has announced that the Apophis asteroid will impact Earth next month. After years of speculation and scientific debate, the truth is finally out. This disclosure is monumental given the potential catastrophic consequences. But what led to this shocking prediction? What unknown factors have brought us to this brink? Join us as we delve into the incredible story behind Apophis and uncover the hidden truths that could change the fate of our planet. In June 2004, astronomers Roy Tucker, David Tholen, and Fabrizio Bernardi were conducting routine observations at the Kitt Peak National Observatory in Arizona. During their search for asteroids low in the western sky, they stumbled upon an object that immediately caught their attention. This object, later named Apophis, was unusually close to the Sun compared to typical asteroids. This discovery would soon become a focal point for astronomers and space enthusiasts alike. Why the name Apophis? The asteroid was named after the Egyptian god of chaos and destruction, a fitting title given its potential threat to Earth. Apophis, known as the serpent-like rival of the sun god Ra, symbolized chaos and darkness in ancient mythology. This ominous name perfectly encapsulates the fear and uncertainty surrounding the asteroid's discovery. Initial calculations of Apophis's orbit were alarming. Scientists quickly realized that this 370-meter-wide asteroid had a significant chance of impacting Earth. The initial estimate suggested a 2.7% probability of collision on Friday, April 13, 2029. This potential doomsday scenario sparked a media frenzy and fueled numerous conspiracy theories about the end of the world. What would happen if Apophis actually hit Earth? The impact would release energy equivalent to over 1,000 megatons of TNT, far surpassing the most powerful nuclear explosions. This catastrophic event would result in widespread destruction, massive loss of life, and long-lasting environmental damage. The fear of such an impact gripped the public, and the story of Apophis became a staple in discussions about potential asteroid threats. Despite the initial panic, NASA and other space agencies worked tirelessly to refine their calculations and predictions. Over time, they gathered more data and improved their understanding of Apophis's trajectory. By 2006, NASA declared that the likelihood of an impact in 2029 was extremely low, reassuring the public that the asteroid would merely be a spectacular sight in the sky. Curiosity and concern about Apophis never completely faded. Scientists continued to monitor its path, aware that any slight change in its orbit could alter its future trajectory. This ongoing vigilance was important as Apophis was set to make another close approach to Earth in 2036. Once again, calculations showed that the risk of impact was minimal, but the asteroid remained under close observation. But how did we arrive at the current prediction of an impact next month? What new information did Cern uncover that led to this alarming revelation? As we look back at the history of Apophis, it's clear that this asteroid has always been shrouded in a mix of scientific intrigue and public fear. Its discovery, naming, and initial threat predictions have set the stage for the current situation. The story of Apophis is far from over, and the next chapter could be the most critical yet. In the wake of Cern's shocking revelation that Apophis will impact Earth next month, it's necessary to understand what asteroids are and how they behave. This knowledge helps us grasp the gravity of the situation. So what exactly are asteroids, and how does Apophis compare to other space rocks? Asteroids are rocky, airless remnants from the early formation of our solar system, about 4.6 billion years ago. These celestial objects, often referred to as minor planets, orbit the Sun just like planets but are much smaller. Most of the known asteroids can be found in the asteroid belt, a region between Mars and Jupiter. This area is teeming with thousands of these space rocks, ranging in size from tiny pebbles to gigantic boulders. But how are asteroids different from meteors and meteorites? Let's break it down. A meteor is a space rock that enters Earth's atmosphere. As it burns up due to friction with the air, it creates a bright streak of light, commonly known as a shooting star. If a part of the meteor survives the journey through the atmosphere and lands on Earth, it's called a meteorite. In contrast, asteroids remain in space and orbit the Sun, rarely making contact with Earth. Now let's focus on Opus. This particular asteroid stands out due to its significant size and its alarmingly close trajectory to Earth. Opus measures about 370 meters in diameter, roughly the height of the Empire State Building. This makes it one of the larger asteroids that have come near our planet. So, how close is Opus expected to get? The trajectory of Opus brings it within approximately 30,000 miles of Earth's surface. To put that into perspective, that's closer than some of our satellites orbiting the Earth. Such proximity raises serious concerns about the gravitational pull of our planet potentially altering Opus's path, increasing the likelihood of an impact. The announcement from Cern has sparked new concerns and rumors about how well-equipped we are to handle this kind of threat. Due to its size and course, the asteroid is a dangerous foe that needs to be avoided or lessened quickly with concerted actions. But what steps are being taken to address this looming threat? What techniques and innovations are being created to protect our planet? Understanding the nature of asteroids and the specific characteristics of Opus is significant as we navigate this impending crisis. The more we know about these space rocks, the better equipped we are to devise effective defense mechanisms. The revelation that Opus is set to impact Earth next month underscores the importance of scientific vigilance and preparedness. The scale of destruction would be unprecedented. To put it in perspective, consider the meteor crater in Arizona created by a much smaller asteroid about 50,000 years ago. That impact released energy equivalent to 10 megatons of TNT and left a crater nearly 1.2 kilometers in diameter. Now imagine an impact over 100 times more powerful. The Tunguska event in 1908, which flattened over 2,000 square kilometers of forest in Siberia, was caused by an asteroid explosion in the atmosphere with an estimated energy release of 10 to 15 megatons. Opus's impact would dwarf both these events in terms of energy and destruction. The immediate effects of the impact would be catastrophic. A massive shockwave would radiate from the impact site, destroying buildings and infrastructure and causing widespread fires. The intense heat and pressure would instantly incinerate everything in the vicinity. But the devastation wouldn't end there. The impact would eject massive amounts of dust and debris into the atmosphere, blocking sunlight and leading to a dramatic drop in temperatures worldwide, a situation known as an impact winter. What about the global consequences? The environmental impact would be severe. The sudden cooling of the Earth's surface would disrupt weather patterns, leading to crop failures and food shortages. The reduction in sunlight would hinder photosynthesis, affecting plant and marine life, and disrupting ecosystems. Acid rain could result from the vaporized material, further harming the environment. The affected areas would suffer greatly from the immediate loss of life and damage to infrastructure. Trade, industry, and financial markets would all be disrupted, hurting the world economy. Massive resources would be needed for recovery efforts, placing a burden on governments and international assistance agencies. Many countries might enter a recession or possibly collapse due to the cost of reconstruction and the long-term effects on the economy. The consequences would be intense. The loss of millions of lives and the destruction of communities would lead to widespread grief and trauma. The displacement of populations would create a refugee crisis, with millions seeking safety and resources. Social order could break down in the face of such widespread devastation and scarcity. Governments would be challenged to maintain stability and provide for their citizens amidst the chaos. How would humanity respond to such a catastrophe? Would international cooperation prevail, or would nations turn inward, focusing on their own survival? These questions underscore the need for global preparedness and cooperation in the face of existential threats. The potential impact of Opus is a stark reminder of our planet's vulnerability and the importance of being ready for such events. It's necessary to think about the actions we can take to reduce these risks and get ready for the worst-case situation. As we continue to investigate the consequences of Cern's declaration, what steps are being taken to safeguard our planet? How can we better prepare for any effects down the road? Join along as we explore the tactics and innovations that might be able to protect humanity from such devastating events. Planetary defense relies on a combination of detection, monitoring, and impact mitigation strategies. One of the primary systems in place is NASA's Planetary Defense Coordination Office. The Planetary Defense Coordination Office is responsible for detecting, tracking, and characterizing potentially hazardous objects that come close to Earth. Using a network of ground-based telescopes, including the Pan-STARRS and the Catalina Sky Survey, scientists can identify and monitor asteroids' paths. But detection is just the first step. What happens if an asteroid is on a collision course with Earth? One of the most promising techniques is kinetic impactor technology. Involves sending a spacecraft to collide with the asteroid at high speed, thereby altering its trajectory. The Double Asteroid Redirection Test mission launched by NASA aims to demonstrate this technique by impacting the asteroid moonlet Demoro. The success of the Double Asteroid Redirection Test could pave the way for future deflection missions. Looking ahead, space agencies are developing more advanced technologies to tackle the threat of asteroids. One of the most ambitious projects is the European Space Agency's Hera mission, which will follow up on the Double Asteroid Redirection Test's impact to study its effects in detail. By understanding how the asteroid's trajectory was altered, scientists can refine their models and improve future deflection techniques. Another innovative approach being explored is the use of gravity tractors. This method involves placing a spacecraft near the asteroid and using its gravitational pull to slowly change the asteroid's path over time. This technique requires precise calculations and long-term planning but offers a non-destructive way to prevent impacts. Nuclear options are also on the table, though they are considered a last resort. Using a nuclear explosion near the asteroid could change its course, but this method carries significant risks and uncertainties. The potential for breaking the asteroid into multiple hazardous fragments must be carefully considered. While these technological advancements are crucial, public awareness and preparation play an equally important role. Understanding the threat posed by asteroids and knowing what to do in the event of an impact can save lives. Governments and space agencies must prioritize educating the public about these dangers. First, the importance of staying informed through reliable sources cannot be overstated. Misleading information and conspiracy theories can cause unnecessary panic and hinder effective response efforts. Agencies like NASA and ESA provide up-to-date and accurate information about potential threats and mitigation efforts. Emergency preparedness is also necessary. Communities should have plans in place for potential evacuation or sheltering in the event of an impact. Regular drills and public education campaigns can help ensure that people know how to respond quickly and effectively. In recent years, space agencies around the world have made significant strides in asteroid detection and observation. One of the most notable advancements is the deployment of advanced telescopes and radar systems that allow scientists to track near-Earth objects with unprecedented precision. The Panoramic Survey Telescope and Rapid Response System in Hawaii, for example, has revolutionized our ability to detect and monitor asteroids. This powerful telescope scans the sky every night, capturing high-resolution images that help identify and track potentially hazardous objects. Another groundbreaking development is NASA's NEOWISE mission. Originally launched as an infrared space telescope to study distant galaxies, NEOWISE has been repurposed to hunt for near-Earth objects. By using infrared technology, it can detect the heat emitted by asteroids, even those that are too dark to be seen with traditional optical telescopes. This capability has significantly increased our knowledge of the size, composition, and trajectories of asteroids, including Apophis. International collaboration is key to planetary defense. Space agencies from around the globe are working together to share data, resources, and expertise. One prime example of this is the Asteroid Impact and Deflection Assessment Mission, a joint effort between NASA and the European Space Agency. This mission aims to test our ability to change the course of an asteroid by using a spacecraft to collide with it. NASA's Double Asteroid Redirection Test spacecraft will impact the moonlet Dimorphos, while ESA's Hera mission will follow up with detailed observations of the impact site and its effects. Another collaborative effort is the International Asteroid Warning Network. This global network of space agencies, observatories, and research institutions coordinates the detection and tracking of near-Earth objects. By sharing information and observations in real time, the International Asteroid Warning Network enhances our ability to predict potential impacts and develop effective response strategies. Beyond detection and deflection, scientists and engineers are exploring innovative solutions to mitigate asteroid threats. One promising idea is asteroid mining. By extracting valuable resources from asteroids, we could reduce the threat they pose and support space exploration and industry. Companies like Planetary Resources and Deep Space Industries are developing technologies to mine water, metals, and other materials from asteroids. This could provide essential resources for building spacecraft and habitats, reducing our reliance on Earth's finite resources. Another novel approach is the use of space tugs or gravity tractors. These spacecraft would attach themselves to an asteroid and use their engines to slowly alter its trajectory. By carefully applying small amounts of force over a long period, they could nudge an asteroid off a collision course with Earth. This method requires precise calculations and advanced propulsion technology but offers a non-destructive way to manage asteroid threats. What other innovations might we see in the future? The rapid advancement of space technology and international cooperation suggests that we are better equipped than ever to face the challenges posed by asteroids. Continuous research and development are crucial to staying ahead of potential threats. Throughout Earth's history, asteroid impacts have played a significant role in shaping our planet. One of the most well-known impacts is the Chicxulub event, which occurred around 66 million years ago. This massive asteroid, estimated to be about 10 kilometers in diameter, struck the Yucatan Peninsula in present-day Mexico. The impact created a crater over 150 kilometers wide and is widely believed to have caused the mass extinction that wiped out the dinosaurs. The energy released by this impact was equivalent to billions of nuclear bombs, triggering fires, tsunamis, and a nuclear winter effect that drastically altered the climate. Another notable impact is the Tunguska event of 1908. A small asteroid or comet, roughly 50 to 60 meters in diameter, exploded in the atmosphere above the Tunguska River in Siberia. The explosion, equivalent to 10 to 15 megatons of TNT, flattened over 2,000 square kilometers of forest. Remarkably, there were no direct human casualties, yet the incident demonstrated the possible destruction that even a tiny space pebble may bring about. These past impacts teach us several critical lessons. The scale of destruction from even a modestly sized asteroid can be immense. The Chicxulub and Tunguska events demonstrate the range of possible consequences, from mass extinctions to localized but still catastrophic damage. This underscores the importance of early detection and impact prediction. The historical record emphasizes the need for robust planetary defense strategies. Understanding the trajectories and compositions of near-Earth objects is essential for developing effective mitigation techniques. The significance of global collaboration and resource sharing in identifying and countering such threats is underscored by historical occurrences. These impacts remind us of the vulnerability of our planet and the fragility of life. They serve as a stark reminder that we must remain vigilant and proactive in our efforts to protect Earth from future asteroid impacts. The fear of asteroid impacts has been a recurring theme in media and culture. Movies like Armageddon and Deep Impact have dramatized the potential devastation of an asteroid collision, capturing the public's imagination and fear. These films often depict heroic efforts to save the planet, reflecting our hopes and anxieties about dealing with such existential threats. The issue of asteroid strikes has also been explored in literature and media, focusing on the emotional and scientific difficulties that arise in such circumstances. These cultural depictions can influence public perception and understanding of the risks, as well as the importance of scientific and governmental efforts to mitigate them. The fascination with asteroid impacts extends to popular science as well. Documentaries and educational programs frequently explore the history of impacts and the ongoing efforts to detect and deflect dangerous asteroids. This widespread interest helps raise awareness and support for planetary defense initiatives. Preparation for an asteroid impact requires coordinated efforts at multiple levels. Governments must lead the charge by developing and implementing comprehensive disaster response plans. These plans should include early warning systems, evacuation protocols, and public communication strategies. Regular drills and simulations can help ensure that everyone knows what to do in the event of an impact. On a community level, local governments and organizations should work together to educate residents about the potential threat and the necessary steps for preparedness. This includes identifying safe shelters, stockpiling essential supplies, and establishing communication networks to keep people informed during a crisis. But how can individuals prepare? Staying informed through reliable sources is crucial. Knowing the risks and understanding the recommended actions can make a significant difference in a crisis. Creating a personal emergency plan, including evacuation routes and emergency contacts, can also help ensure safety and quick response. Living under the threat of an asteroid impact can have intense psychological effects. The constant fear of a potential disaster can lead to anxiety, stress, and even depression. It's essential to address these mental health challenges to maintain overall well-being. How can we cope with this psychological burden? One effective strategy is to stay connected with friends, family, and community members. Social support networks can provide emotional comfort and practical assistance during stressful times. Engaging in regular physical activity and maintaining a healthy lifestyle can help reduce stress levels. Resources for mental health must also be easily accessible to assist people in managing their worry and terror. Governments and healthcare providers ought to give counseling and other forms of support. Campaigns for public awareness can lessen the stigma attached to mental health concerns and encourage people to seek help. Building resilience is key to ensuring rapid recovery post-impact. Resilience involves the ability to adapt to and recover from disasters, minimizing long-term damage and disruption. One critical aspect of resilience is infrastructure. Constructing buildings and infrastructure that can withstand significant impacts can reduce casualties and damage. This includes using durable materials, reinforcing structures, and planning urban areas to minimize risk. Another important factor is economic resilience. Diversifying economies and creating robust financial safety nets can help communities bounce back more quickly from disasters. Governments can support businesses and workers through grants, loans, and insurance schemes designed to provide financial stability during recovery periods. Community resilience is equally important. Strong, connected communities are better able to support each other during and after a disaster. Encouraging community engagement, fostering local leadership, and building networks of support can enhance a community's ability to recover. Education and training play a crucial role in resilience building. Providing education on disaster preparedness and response, as well as training for emergency services, can ensure that everyone is equipped to handle crises effectively. Programs that teach skills such as first aid, search and rescue, and crisis management can empower individuals and communities. Given the gravity of Apophis's imminence, we must think beyond planetary defense and toward space exploration's larger destiny. What are our long-range objectives? How do we make sure that what we're doing will last and benefit all of humanity? Furthermore, how may the fear of asteroids hasten our goals of colonizing space and establishing interplanetary life? Space exploration has a bright and ambitious future. Beyond defending our planet from asteroid impacts, space agencies and private companies are setting their sights on new frontiers. One of the primary goals is the exploration of Mars. NASA's Artemis program aims to return humans to the Moon by 2024 as a stepping stone for future missions to Mars. Establishing a sustained human presence on Mars is not only a scientific endeavor but a monumental leap for humanity. Missions to the outer planets and their moons, such as Europa and Titan, are on the horizon. These missions aim to uncover the mysteries of our solar system and search for signs of life. The European Space Agency's Jupiter Icy Moons Explorer and NASA's Europa Clipper are examples of upcoming missions that will explore these distant worlds. As we push the boundaries of space exploration, it's imperative to ensure that our efforts are sustainable. Sustainable space practices involve minimizing the environmental impact of space activities both on Earth and in space. This includes managing space debris, using renewable energy sources, and developing technologies that reduce waste. The use of reusable rockets, pioneered by companies like SpaceX, is a significant step toward sustainable space travel. Reusable rockets reduce the cost of launching missions and minimize the environmental impact of manufacturing new rockets for every launch. Sustainability also means ensuring that space exploration benefits humanity. This includes fostering international cooperation, sharing scientific knowledge, and promoting the peaceful use of space. Collaborative projects like the International Space Station exemplify how countries can work together for the greater good, conducting research that benefits all of humanity. The impending danger of asteroid strikes has brought attention to the necessity for humanity to give space colonization more careful thought. In the case of a catastrophic occurrence on Earth, establishing colonies on other planets and moons could ensure the survival of our species and act as a buffer against existential threats. Mars is the most likely candidate for space colonization. With its relatively hospitable environment and potential for terraforming, Mars offers a viable option for a second home for humanity. Companies like SpaceX are already working on developing the technologies needed to transport and sustain human life on Mars. The Starship spacecraft, designed for deep space travel, is a crucial part of these plans. Beyond Mars, the concept of space habitats, artificial structures that can support human life in space, is gaining traction. Projects like the O'Neill cylinders envision large rotating habitats that could house thousands of people. These habitats would create artificial gravity through rotation and could be located in orbit around Earth or other celestial bodies. Asteroid mining also plays a role in space colonization. By extracting resources from asteroids, we can support the construction of space habitats and provide materials for building infrastructure on other planets. This approach reduces the need to transport resources from Earth, making space colonization more feasible and sustainable. The future of space exploration is filled with incredible possibilities. From exploring distant planets to establishing colonies in space, our goals are ambitious and far-reaching. Ensuring that these efforts are sustainable and beneficial for humanity is crucial. The threat of asteroid impacts like Apophis underscores the importance of expanding our presence beyond Earth and developing technologies that can protect and sustain us.